In Part 5 of the Unit 9 notes, we will be covering limiting and excess reactant calculations. Limiting reactant. The reactant which runs out first in a chemical reaction and determines how much product can form. It is not necessarily the reactant that you have the least of, since it can be used at different rates. Excess reactant. The reactant or reactants which are left over when a reaction stops. The identity of the limiting and excess reactants and the quantity of excess reactant at the end of a reaction can be determined by comparing the moles of reactants available with the moles of reactants required to make the product. In this example, we are given 50 grams of silver and 10 grams of sulfur, and we are trying to determine what the limiting reactant is. One way you can do this is by converting each of the gram values that you're starting with into moles. So we had 50 grams of silver, we do a one-step mole conversion, and we have 0.464 moles of silver. You have 10 grams of sulfur, you do a one-step mole conversion for that, and you end up with 0.312 moles of sulfur. So both of these amounts are the amount of moles of silver or sulfur that will be required in order to drive the reaction to completion. Your next step would be to take one of these two values, so here we're starting with the moles of silver, and you convert that into the actual amount of the other reactant that you would need. So here I can convert from moles of silver to moles of sulfur using a one-step mole conversion. I'm getting the 2 and the 1 from the balanced equation, so I can see that for every 2 silver, I need 1 sulfur. So when I finish this conversion, what this tells me is that I would need 0.232 moles of sulfur to completely react all of this silver. Now what you need to do is compare how much sulfur you're starting with and how much sulfur is actually required. Because we have more sulfur over here, 0.312, than what we actually need, 0.232, then sulfur must be the excess reactant. It's the thing that we have more than enough of, which means that our other reactant, silver, must be the thing that runs out first. So in this situation, silver would be the limiting reactant. All right, in this example, we are trying to determine the mass of the excess reactant. Now we're actually going to use some of the work that we had from the previous slide, since this is essentially the same problem. So if you remember, we converted to the moles of sulfur, so this is how much sulfur we were starting with. We're subtracting away the amount of sulfur that we would have needed, 0.232, and then we figure out that we have 0.080 moles of sulfur excess. That amount of moles of sulfur excess can be converted back into grams. So we do a one-step mole to gram conversion, and we end up with 2.57 grams of sulfur. All right, now for our first checkpoint question, we're going to be going through this process. The first thing that we are asked is to determine the limiting reactant when we're given 25.0 grams of phosphorus and 50 grams of oxygen. So the first thing I'm going to do is write down 25.0 grams of phosphorus, which is P4, and I'm going to figure out how many moles that would be. Grams is going to go on the bottom since that's what I started with, moles on top. 1 mole is equal to the mass on the periodic table. Now because this is P4, I need to multiply the mass of phosphorus by 4. So I have 123.88 grams of P4. When I multiply across and round for the 3 significant figures that I started with, I have 0.202 moles of P4 available. So that's how much I'm starting with. Now for the 50 grams of oxygen, so 50.0 grams of O2. I'm going to do a one-step gram to mole conversion for that. Now for this one, because oxygen is a diatomic element, notice the 2, I'm going to multiply that mass on the periodic table by 2. So I have a mass of 32.00 grams. If I multiply and divide across there, I have 1.56 moles of O2 available. All right, next, I'm going to pick one of these two values, I'm going to use the 0.202 moles of phosphorus, and I'm going to convert that to moles of my other reactant, in this case oxygen. So moles of phosphorus on the bottom, moles of oxygen on top. Based on my balanced equation, there are 5 oxygens that are needed for every 1 phosphorus. So this is 5 over 1. When I multiply across, I can see that I have 1.01 moles of oxygen, which are required. All right, so now I'm going to look at how much oxygen is needed versus how much is available. And based on these two numbers, I can see that I have more than enough oxygen. So O2 is my excess reactant, which means by default, my phosphorus, which is P4, is going to be my limiting reactant. And in this particular question, that's what they were asking me for. I just had to identify the limiting reactant. So P4 is going to run out first in this reaction. This next checkpoint question is kind of a follow-up. So we have the same exact masses for each of our 2 reactants. This time we're trying to figure out the mass of that excess reactant. So since this is a follow-up, I'm going to continue to use the work that we already had from the previous slide. So we had identified 1.56 moles of oxygen, and we're going to subtract the 1.01 moles of oxygen that would actually be required. So this is how much that we had available to us, and this is how much was needed for the reaction to work. When we subtract that, we end up with 0.55 moles of oxygen excess. But this is not my final answer because I want the mass of excess, not the number of moles. So I need to convert this back out to a unit that makes more sense for mass, grams. So I'm going to take my 0.55 moles of O2. I'm going to do a one-step mole conversion. So moles of oxygen is going to go on the bottom. Grams of oxygen is going to go on top. 1 mole is equal to the molar mass. For O2, that was 32.00. When I multiply across, I get 17.6, but I only have 2 significant figures here. The 0 out in front doesn't count, so I'm going to round that to 18. 18 grams of oxygen is my excess, so that's all the leftover oxygen we're going to have. In this checkpoint problem, we are going to try to determine the mass of product that could be formed when we're given the same 2 masses of reactants from the previous problem. So this is another follow-up question. What we want to do is use our limiting reactant, which was this one. We had already determined that this one would run out first, and we're going to do a 3-step conversion in order to convert that to our amount of product. So I'm going to start out by writing 25.0 grams of P4 and set up a 3-step conversion. And I'm going to eventually go to grams of the product. So I have grams of P4 to moles of P4, then moles of P4 out to moles of P4O10, and then moles of P4O10 to grams of P4O10. 1 mole is equal to the molar mass. We already added that up before. That was 123.88 grams. The mole-to-mole ratio is from the balanced equation, so this is a 1-to-1 relationship, so 1 over 1. And then for our last part, we have 1 mole for the molar mass. So I have 4 phosphorus and 10 oxygen that I have to add up. So it's going to come out to 283.88 grams. When I multiply across, that is 48.2 grams of P4O10. So this is the amount of product that we would be able to make if we use up all of our limiting reactant. That concludes part 5 of the Unit 9 notes. In part 6, we are going to cover percent yield calculations.